So I want to talk a little bit about these related indeterminate forms now that you had the first review of L'Hopital's. And the related indeterminate forms that I'm after in this lesson is really 1 to infinity, 0 to 0, or infinity to 0. And they result from taking a limit of a function that looks like this. Okay? You're going to approach some value of a, and the functions are going to look like this. All right? So you've got some f of x, and you've got f of x raised to some other function, g of x. All right? So those limits are going to result often in an indeterminate form of one of those three types. So there's a procedure that we can use to handle them, and we need to basically get them into the form, right? So you want to somehow transform this f of x to g of x, right, into something that we can use L'Hopital's rule on. So you need to get them into 0 over 0 or infinity over infinity. And to be able to do that, we're going to use logarithms, right? Because remember, logarithms will unlock this exponential function. So the procedure is basically this. We're going to grab my pencil back color. You're going to evaluate a limit. We'll call it L. And we're going to rewrite this function in the form of logs. Because remember, what we just did was take the log of this. And what is that going to do? Make the exponent become the constant multiplier, which is this. And then you took the ln of the function. Okay? So we're rewriting that function in this term. All right? And we'll do some techniques with it ultimately, but the goal is we're going to use L'Hopital's rule on that. And you might ask, well, this is 0. This may be 0 times 0 or infinity times infinity, but we'll use the trick that we used prior in order to get it into 0 over 0 or infinity over infinity. We'll do an example. The second step then is just to actually take the limit now, or the answer really, putting it together of this. Once you obtain this value of L, then the limit is going to be e to the L. All right, so that now becomes an exponent because we're going to undo the logarithm with the exponential function. Okay, so that's theoretically, that's pretty much what you're doing. Let's see how it plays out with an example. All right, let me come in here real quick. I'm going to pause.